On August 21, 1986, a lake in Cameroon, Africa, exploded. There was no fire, no lava, just a silent, invisible force that erupted from the water's serene surface. This was not a typical eruption, it was a geological paradox. The event unleashed over 1.6 million tons of carbon dioxide gas. This colorless, odorless cloud, heavier than air, poured over the lake's rim. It moved like a phantom river, silently flowing down into the surrounding valleys, displacing the very air people breathed. To understand this silent disaster, we must look deep beneath the Earth's crust. Lake Nyos is not an ordinary body of water. It is a maar, a deep crater lake formed by a volcanic explosion sitting directly atop the Cameroon volcanic line, a chain of ancient and active volcanoes. Beneath the lake floor, a pocket of magma, the heart of this volcanic system, constantly releases gases. For centuries, carbon dioxide seeped upwards through fractures in the rock, dissolving into the groundwater that fed the lake from its very bottom. This was the engine of the disaster. But a crucial question remained. Why didn't this gas simply bubble to the surface over time? The answer lies in the lake's unusual structure. Lake Nyos is a meromictic lake. Its water layers do not mix. In the stable tropical climate, there are no significant seasonal temperature changes to trigger turnover. The colder, denser water at the bottom remains trapped, physically separated from the lighter, warmer surface water. This deep layer became a perfect, high-pressure container for the incoming gas. The science of this trap is governed by immense pressure. The top 200 meters of water exerted a colossal weight on the layers below. This pressure acted like a natural cork, preventing the dissolved gas from escaping. Essentially, the deeper water became a sponge. Just as a sealed soda bottle holds its fizz under pressure, the lake's depths absorbed more and more carbon dioxide. The gas was forced to dissolve, becoming one with the water. This process continued for decades, perhaps centuries. The bottom layer became dangerously supersaturated, a state of profound chemical instability. At its peak, every single liter of water at the bottom of Lake Nyos held an astonishing 5 liters of dissolved carbon dioxide. Visualize that contained energy. The gas, compressed and dissolved, held a potential force far greater than a conventional explosion. If that pressure were ever released, the volume of the gas would expand by a factor of 1,000, erupting from the water with unimaginable speed. This liquid bomb held the potential energy of a small conventional explosion. It was perfectly stable, a system in a delicate, deadly balance. It just needed one push. The exact trigger remains a subject of intense scientific investigation. One leading theory points to a landslide. A significant mass of rock and soil from the crater's steep rim could have suddenly collapsed into the lake. This sudden displacement would have acted like a giant plunger, forcing the deep gas-saturated water upward into zones of lower pressure. Another possibility is a small volcanic tremor, a subtle shake from the magma system far below, just enough to disrupt the fragile stratification of the water. A third scenario is deceptively simple. Cool, dense rainwater from a heavy storm could have plunged through the warmer surface, penetrating deep enough to disturb the boundary layer. This would have been enough to initiate the ascent of the carbonated water from the depths. Regardless of the trigger, the result was a catastrophic, runaway chain reaction. As that initial pocket of deep water began to rise, the immense pressure holding the carbon dioxide dissolved within it, decreased. The gas began to violently fizz out of the water. This process is called exsolution. It is the same physical principle that causes a shaken bottle of soda to erupt. The sudden infusion of countless gas bubbles made that column of water far less dense, causing it to accelerate toward the surface even faster. This created a terrifying feedback loop. A faster ascent led to a greater pressure drop. A greater pressure drop unleashed even more explosive gas release. This self-sustaining process, a limnic eruption, turned the entire deep layer of the lake into an unstoppable geyser. The physical result was a display of immense power. The eruption was not fire, but water. A colossal fountain of water and foam shot more than 100 meters into the night sky, higher than a 30-story building. This violent upwelling displaced a huge volume of the lake's water. It created a powerful wave that scoured the shoreline, stripping away vegetation and soil down to bare rock. But the visible destruction was only a prelude to the silent killer. The real weapon was invisible. The eruption released an estimated 1.2 cubic kilometers of carbon dioxide gas. This immense cloud, 1.5 times denser than air, hugged the ground, flowing silently down the surrounding valleys like an unstoppable, suffocating river. The aftermath was not one of violent destruction. It was one of profound, chilling silence. Because the carbon dioxide cloud was denser than air, it flowed down the valleys like an invisible river. It displaced the very oxygen needed for life. This left a landscape that was eerily pristine, untouched, but utterly lifeless. Survivors spoke of a sudden quiet that fell across the land. The constant hum of insects ceased. Birds fell from the sky. The gas itself was odorless and colorless, but it carried with it sulfurous compounds from the deep earth, creating a smell often described as gunpowder or rotten eggs. It was the scent of the planet's inner workings, brought to the surface. In the wake of the disaster, an international team of scientists confronted a terrifying question. How could they stop this from happening again? The answer was an elegant feat of engineering born from a deep understanding of physics. They would give the lake a permanent, safe way to release its pressure. They would build a degassing pipe. The solution acts as a controlled, artificial siphon. A pipe was lowered hundreds of feet into the carbon dioxide-rich bottom layer of Lake Nyos. To start the process, water was briefly pumped up the pipe. As this deep water rose, the pressure upon it decreased, allowing the dissolved CO2 to bubble out of solution, just like opening a bottle of soda. These bubbles lowered the density of the water inside the pipe, causing it to rush upwards with even greater force. This action pulled more gas-rich water from the lake bed into the pipe's base, creating a self-sustaining fountain. A continuous, controlled eruption now safely vents the gas into the atmosphere, a plume of water marking the spot where human ingenuity disarmed a geological time bomb. The investigation at Nyos led to a more alarming discovery. This was not an isolated phenomenon. We now turn our attention to Lake Kivu, on the border of the Democratic Republic of Congo and Rwanda. It is a body of water 2,000 times larger than Nyos, and it holds an estimated 300 times more dissolved gas. Lake Kivu presents an even more complex challenge. Its deep waters are not just saturated with carbon dioxide. They also contain vast quantities of methane. This combination makes Kivu a potential source of energy, but it also elevates the hazard. A disturbance here could trigger an event of an unimaginable scale, threatening millions of people who live along its shores. The tragedy of Lake Nyos fundamentally changed our understanding of the planet. It introduced the world to a new, terrifying type of natural hazard, a limnic eruption. It proved that even the most serene landscapes can conceal immense and volatile power, hidden just beneath the surface. It serves as a humbling reminder of Earth's hidden mechanisms. Our planet is a dynamic system, constantly in motion, with powerful processes unfolding in places we cannot see. The silent explosion of Lake Nyos was not an act of malice. It was the Earth breathing, and a profound lesson in the importance of scientific curiosity to listen to its whispers. The lesson of Lake Nyos extends far beyond Cameroon. It created a new field of scientific inquiry. Now, a global network of sensors and researchers monitors geologically active lakes, listening for the deep, silent hum of dissolved gases. These sentinels stand guard against a threat few knew existed before 1986. Nowhere is this vigilance more critical than at Lake Kivu, on the border of Rwanda and the Democratic Republic of Congo. This lake is nearly 2,000 times larger than Nyos, and it holds over 300 times more dissolved gas. The energy contained within its depths is immense. The gas composition in Kivu presents a further complication. Along with carbon dioxide, its deep waters are saturated with methane. This makes the lake a potential source of energy, but also a far more complex and volatile system to manage. A degassing event here would be catastrophic on an unimaginable scale. This is not an abstract scientific problem. Nearly 2 million people live along the shores of Lake Kivu. Their lives unfold in the shadow of this vast, submerged chemical battery. The science of limnology and volcanology has become a frontline defense for entire communities. The revelation at Nyos prompted a crucial question. How many other lakes on Earth hold a similar secret? These events are called limnic eruptions. They are exceptionally rare, requiring a precise and unlucky combination of geology and geography. The search for these potentially explosive lakes is an ongoing scientific frontier. Researchers examine crater lakes along volcanic chains worldwide. They probe their depths, analyzing water chemistry and temperature gradients. They are looking for the telltale signs of stratification and gas saturation. This shifts our perspective on the planet's dangers. We are accustomed to the visible fury of volcanoes, earthquakes, and hurricanes. But Earth also possesses silent, hidden mechanisms. These are traps set by geology over millennia, waiting for a single, small trigger. The core insight is one of pressure and release. The Earth is constantly venting heat and gas from its interior. Usually, this process is slow and diffuse. But in places like Lake Nyos, a body of water can act as a cap, suppressing this release and allowing immense pressure to build. This is a profound truth about the world. The planet is not a static rock. It is a dynamic and layered system, with immense energy moving through it. The surface we inhabit is just the thin boundary where these powerful internal forces meet the atmosphere. The tragedy of Lake Nyos was not an act of malice. It was a physical process, indifferent and absolute. It was the planet breathing. And in that single, silent exhalation, we learned how deeply interconnected the systems of rock, water, and air truly are.